Right for now, I'm going to write moles equals. You're going to find out later that the symbol for moles is actually N, because M is taken for mass and capital M is taken for molarity. All right, so we usually call it, whoa, let me get caught up again. Let's do that. Okay, so they give me the moles, and they also give me a volume. They tell me that this thing is in 10 milliliters of solution, 10.0 milliliters. But I need to be in liters. So I get rid of milliliters, go to liters. Liter means 1, milli means 0.001, or this is 0.0100 liters. Okay, so everybody good with that so far? All right, that's not too big a stretch at all. We just got moles and we got liters. That's the things we need up here. But the thing we got to keep in mind is this is moles of the compound, not moles of ions. So there's a couple ways we could do it, but one way I would do it is just to calculate, say, the molarity of Na3PO4. So that would be, the molarity would be 0.0200 moles of Na3PO4 over 0.0100 liters. That should be easy. Shouldn't that just be 2 molar? If you divide that into that. Okay, so that's going to be 2 molar Na3PO4. Everybody good with that so far? Everybody with me? Just calculating molarity, right? Moles per liter. You know how to get moles. You know how to get liters. Now here's the thing where we're going to put something together from earlier in this chapter. When you put this into solution, this thing's going to dissociate. And what's it going to dissociate into? Well, Na3PO4 solid, when placed into water, will separate into 2 parts, Na and PO4. I look up their charges. Sodium's group 1, so that's +1. I look up phosphate polyatomic ion, that's -3. So I can get those off my periodic table and polyatomic ion sheets. These are both going to be in the state of aqueous because they're dissolved now, so these are both AQ. And if I have more than one of any of these, I got to use a coefficient. So I have 3 NAs, but I only have one group of PO4. If I had more PO4s, wouldn't I have parentheses around it and a number? Okay, so if I have more than one polyatomic ion. So this breaks down into this, which is 4 ions. So it's breaking into 4 different pieces. Yep.
For the yield thing, do you want us to always put water over it?
I'm not going to lose my mind if you don't, but that's just to make a point. Yeah. A lot of times, put it this way: when we write chemical equations, a lot of times what we do is we put catalysts up here or things that are needed for the reaction or needed for this to happen, but not necessarily part of the end product. Okay. So a catalyst is something that makes a reaction happen quicker or happen that wouldn't have happened. So anyhow, if you put water, I'd prefer it, but it's not. I wouldn't mark you wrong for it. Okay, now 2 molar Na3PO4. Isn't that the same thing as saying 2 moles of Na3PO4 per 1 liter? Same thing, right? I'm just expanding the M. And the reason why I'm expanding it is because now I can get rid of moles of Na3PO4 and turn it into moles of ions. And we said there's 4 moles of ions for every 1 Na3PO4. For every one of these, I get 3 of these plus 1 of those. So every one I get 4. And so if I multiply that out, what's that going to be? 8 molar, 8 moles of ions per 1 liter, or you could say 8 molar ions. Okay. Okay, now just to be clear, that's a lot of writing for something. I probably wrote more than I need to, that I would probably write if I were taking a test like this. What I probably would have done is I would have started out with moles of ions. I probably would have just thrown that in there. I might have done that in my head. I usually write it down just for my answer keys and stuff, but I can do that in my head at this point. You probably can too. But the thing is, the reason I keep showing you this is What are you going to do if I give you microliters? What am I going to do if I give you something different? Okay. So again, the flip it thing. So I might have just started by plugging these numbers in right away. So I might have eliminated all that writing right there. The other thing I probably would have done is after I multiplied this, I probably would have skipped writing that and skipped writing that, and I would have gone right to this. I could have gone right to this step. Because see, moles of Na3PO4 could cancel right here. And so I wouldn't necessarily have to stop and get that intermediate step. So basically what I'm saying is this. What really is necessary for those of you guys that are trying to not do too much extra work is I would probably do this and then go straight to this. And I would also need this. But then again, I could probably get by without even writing that equation too, right? If I look at this, I go, well, that's going to split into 4 pieces, if you can see that. If you can't, write out the equation. So the most necessary parts are that and that. The other stuff's just there to make a point, you know, so I can teach to you. How are we with that? How many guys think they can do that? 3, 6. Okay, a few. All right, so we'll move on. Everybody good with this one? You want to try another one like this, but you guys do it this time? Okay. Okay. So let's try 24B. Okay, so 24B says, again, calculate the concentration of all ions present. So we want concentration of all ions present. All right. And they're giving me a couple values here. They're giving me 0.3 moles of barium nitrate. And they're giving me volume, 600 milliliters. Okay, let's see. I'll call some people up here. Right now, my suggestion would be maybe you use the example I just gave you. We have some examples like that in our notes too. Concentrations of ions. So why don't we use those as an example. Start out first person. Nick Wenzel. And I forgot, happy belated birthday. I forgot yesterday. I knew I had some birthday. I was going to get like a candygram to come, and I'm just kidding. Did you have a good celebration?
Yeah.
Yeah. Did you get a gold-plated Cadillac? No. No, you didn't get one? Okay.
What is the
That's the problem, right? I got some in my books there. Just find some, yeah. There's one, and there's probably one in here someplace. Did I put them all away? That's all right. I'll get one because somebody else is going to need it anyhow. I must have put them all away. There you go.
Hey, Ethan. Hey, Gary. Good when you were inside.
How cold does it get at in your home? Coldest?
No, not cold at all.
I know. So like what?
It's very
Like
warm throughout the season.
like probably like coldest, say 20 Celsius, maybe a little less.
15.
15?
Celsius.
Yeah, that's pretty warm.
Yeah,
15 is probably in the 60s, probably 60s, something like that.
Yes.
Oh, really?
Yeah.
Yeah.
What's that?
And the rings
So,
are up.
where are you near Shanghai?
Oh, yes, close to Shanghai. Yeah.
Yeah, so like
South of Shanghai.
yeah.
Please pardon the interruption. Hey, great job today, both at the rally, outside, and getting back to class on time.
Oh, that's wait, hold up.
Well
Hold up.
done. never had any doubt that you could do it.
I just want you to do one thing at a time, so that's okay. You're not wrong. You're not wrong. But I want to address something on this too. Okay.
And because we got done early, we're going to change periods a little bit. So teachers just jot down, we'll be in second period until 10:15. And then at 10:18, we'll be in third period till 11:05, which will then get us back on the regular AM lit schedule. Any questions, just send me an email. Great job once again, and hopefully we'll see everybody there tomorrow. Take care.
Okay, now one thing I'd say is, okay, you're identifying moles like that. You got the 0.3, that's good. You should have a unit mole. And also, too, we should write this above so we can crisscross and get what it is. You follow me?
Yeah.
Okay.
What was it? I'm confused.
Okay, so you got the mole, that's good. What's the charge of a barium?
+2.
Plus 2. Okay, so what number are you bringing down to barium?
1.
1, because that's a -1, but we don't write ones, right?
Yeah.
Okay, what are we bringing down to NO3?
2.
2, but you're writing, that looks kind of odd, doesn't it?
Yeah.
So what do you need? There you go. Oh, now this should be a subscript. Good, okay. So we had to crisscross to get a formula, so I like that, that's good, you're off the hook.
All right.
Good, I'll scoot past you. So look, he said, okay, this is what was given. You got to turn barium nitrate into a formula, all right? And so now we're good to go. Okay. By the way, do you guys realize that? And I know some of you guys, when you see nomenclature, you might be, you got to be kidding me. I got to still know that stuff. Think about this though, okay? It in general is easier to go from name to formula than formula to name, in general. Okay. Secondly, do you notice that everything we're talking about is ionic? Okay. So that means everything's going to crisscross. Do you see what I'm saying? So, I mean, really, the thing that I need you to be able to do most is get from a name to a formula, right? Getting from formula to name, that's great if you're typing up a report or something like that, right? But we're typically interested in the math, so we're interested in the coefficients and subscripts and that kind of stuff. So when you think about it, if you have to review any nomenclature, review crisscrossing. That's the main thing that you're going to come across. Okay, so Garrett Height, what you going to do next?
Volume.
Okay, let's do one thing at a time. He's going to do volume.
Do they always come out perfectly the previous example when you're trying to?
What, like 2?
Yeah.
No.
Okay.
No. And I have no guarantees for what the answers are actually when you take a test, because usually what I do is I just kind of pick numbers out of the air.
All right. So we need a calculator or something.
Yes, absolutely. Yeah, knock yourself out. There's one up there. Is that George Orwell you guys reading? Oh, Scarlet Letter. Ooh.
Oh, it's over though. I don't know why I haven't given it back to you.
It was not a good book.
Didn't like Scarlet Letter?
It's hard to
Not
understand.
poorly. I mean, I liked the story, but I didn't like the book.
Honestly,
the story was beautiful,
Mm-hmm.
but I mean,
SparkNotes helped me a lot.
I'll tell you, I was not really good about reading the books when I was here that well, but I'll tell you, I liked 1984. I thought that was a cool book. Are you guys, some of you reading it now?
Animal Farm was good.
Animal Farm was good
I
too.
like that.
Yeah, I agree.
I
Okay, good.
I could write on the book.
Okay, John Vergutz. Where are you going to go? Something productive. When I say concentration, you think.
64.
When I say concentration, you think molarity, right? So you got to have those two words in your head together. Concentration is molarity. And what I like is he's writing down molarity of the barium nitrate, because again, we're starting to get into problems where you're calculating, say, molarity, but you might have several molarities. You might have several moles. And if you're just writing mole or molarity, you don't know what you're talking about. You know, you really can get confused very easily.